Power of a power property. This is in section 7.3. This is our second property that we're learning in this section. Our first property that we learned was power of products property, where we added our exponents, and now we're going to learn how to do something different with our exponents. So a power raised to another power equals that base raised to the product of the exponents. That sounds like gibberish, so let's make it make sense. A power, or an exponent, raised to another exponent. So essentially, this situation that we have here, we have 6 to the 7th power, which is also again raised to the 4th power. That is equal to the base. In this case, we have a 6 raised to the product of the exponents. So in other words, we're going to multiply the exponents. We're going to times those exponents. So following that rule, we have 6 to the 7th power, so we can rewrite this as saying 6 to the 7th times 6 to the 7th times 6 to the 7th times 6 to the 7th. And the reason why I did this is we have an exponent of 4. So we're multiplying everything that was inside of the parentheses 4 times over. Now we could then also say that 6 to the 7th, that is essentially 6 times 6 times 6 times 6 times 6 times 6 times 6. And we could do that all 4 of these times, but I'm totally not going to. What I can see here is I'm going to do this 7 times, 7 times, 7 times, 7 times. So we could follow our last property where we added the exponents, and we could say 7 plus 7 plus 7 equals 28. Another way that can be written is 7 times 4. 7 4 times equals 28. So the answer to this particular problem of 6 to the 7th raised to the 4th power is 6 to the 28th power. So let's practice this property, this power of a power property. Okay, so let's go to our first practice problem. We have 3 to the 4th to the 5th power. Now we know we can write this 3 to the 4th 5 times, so we could rewrite this as 3 to the 4th times 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 3 to the 4th. So that means we could add our exponents of 4 plus 4 plus 4 plus 4 plus 4, but we totally don't need to do that. Instead, what we can do is we can say 4, 1, 2, 3, 4, 5 times, and if I look at that, there's my exponent of 5, and there's the exponent of 4, and that equals 20. So our final answer for this is 3 to the 20th. So I could just have said 4 times 5 is equal to 20. This next problem, let's look at this 6 to the 0 power raised to the 3rd power. So we have 6 to the 0 power raised to the 3rd power, so let's do 0 times 3. That equals 0. So this can be rewritten as 6 to the 0 power, and what we know about 0 powers is that is all going to equal 1. So either of these can be final answer. I suppose this is simplest form, and this is it evaluated. Last problem here. Let's look at this last problem before everybody comes in for lunch. We have a to the 3rd power raised to the 4th power, and a to the negative 2nd power raised to the 3rd power. Using simply this powers to a power property, let's look at just these first couple of things. We have a to the 3rd power raised to the 4th power. This can be, if we're just looking at the exponents, we could say exponent of 3 times exponent of 4 equals 12. So we have a to the 12th power for this first part. And this next part is a to the negative 2 raised to the negative 3. So we could do negative 2 times negative 3, which equals 6. So that can be rewritten as a to the 6th power. So total, if we were to look at all this, we have a to the 12th power times a to the 6th power. That is both of these simplified, which is also equal to, now our power or product of powers property, a is 12 plus 6 So A to the 18th. Hope this helps.